Hello and welcome to another episode of Study Session for AP Physics 1. And in today's video, we will be covering work power, and that's pretty much it, just work and power. I guess for that matter, also a bit of energy, because that kind of comes with work and power, because work is just the transfer of energy, and then power would be the transfer of energy over time, basically the rate of the transfer of energy. Okay, so let's first start out with some formulas. So the formula for work equals force times distance times your cosine of theta, where theta is the angle between your force vector and the vector of your motion. So like let's say you were moving in the let's just call this plus x, but then your force was actually directed like this. Okay, so your theta would be the angle between them. And work can be negative, so you always need to remember that. And net gravitational work is, or gravitational work for that matter, is path independent. So yeah, so power equals work over time, okay? And so net work equals change in kinetic energy. So if we change that to be net, work net equals change in kinetic energy, whereas just work, like each individual, so like let's say you're moving a box up, work equals change in energy though. Okay, so like if you were moving a box, but then you didn't speed it up any, and you're applying a force to counter the gravitational force, you're applying work because you're changing energy, because your gravitational potential energy would be increasing from like point A to point B, but your net work is zero because you like if it's moving up at a constant velocity, like because you'd have your gravitational force down and then your applied force up, so that's why your speed wouldn't change. So like your speed's constant, so your change in kinetic energy is zero, so your net work is zero. However, the work that you applied is not zero because you did do work on that object. It's just there was no net work done on that object. So with that being said, that's pretty much the general premise. However, it's always best to do some practice problems to, kind of find out what to do or whatnot. So let's go ahead and get into that. And why am I using a soft eraser? That will take way too long. Okay, just gonna quickly erase all this and we can get into some practice problems. Okay. So, the first one says, a force of strength 20 newtons, so 20 newtons, oh, that was a really bad end, newtons equals force, and it acts on an object of mass 3 kilograms, so 3 kg equals mass, okay, and it moves a distance of 4 meters. Okay, if F is perpendicular to the 4 meter displacement, the work it does is equal to, okay, so let's draw out a situation, okay, so we've got, let's just say our movement's in the x direction, plus x, because it didn't specify, but it shouldn't matter if it didn't specify. And it says our force is perpendicular, okay? So right now, I know that this angle is 90 degrees. And if we recall our work equation, so work equals force times distance times cosine of theta. Cosine of 90 equals 0. So this whole term is going to be 0, because it's going to be 0 times, 20 times 4, and that equals 0. So we know that, that looks like a 6, that's a 0. So we know that our force will be 0, or not our force, our work will be 0 joules of work done because the force is perpendicular. If it were parallel, we would actually have a value, but it's not, so it is simply 0 joules. Okay. The next problem states that under the influence of a force, an object of mass 4 kilograms, so 4 kg, accelerates. Okay, so we know that we have some acceleration from 3 meters per second to 8 meters per second. Or sorry, 6 meters per second. 3 to 6. 6 meters per second in 8 seconds. Okay. How much work was done on the object during this time? So we can go about solving this two ways. We can go about solving it through a network, or we can do some substitutions in order to solve for the force. So it doesn't specify how much, or it doesn't specify the distance traveled, and I could use kinematics to solve this. However, in this case, it doesn't specify that there's any other forces acting in the opposite direction, so I know that your applied work is going to be equal to net work, so I'm going to use the formula that W net equals change in kinetic energy. And kinetic energy equals 1/2 times the mass times the velocity squared. Okay, so if we go ahead and solve for change in that, it's final kinetic energy minus initial kinetic energy. So we've got 1/2 times 4 times 36, which is 6 squared. So that's where I got the 36, minus 1/2 times 4 times 9, because 9 is 3 squared. So if I quickly do some math, that would be 2 times 36, which is 72. And then that would be 2 times 9, which is 18. So if we do 18 joules, or not 18, sorry, 72 joules minus 18 joules, if we just do some quick subtraction, we change that to 6, this turns into 12, so that's 4, and that would be 54 joules. So we know that our work is 54 joules because in this case, our net work was our work applied, and that work applied equals change in kinetic energy, so we use the change in kinetic energy. You also could have solved this using kinematics. You could have solved for the acceleration, solved for the displacement. And then using the acceleration and the mass, you could solve for force, because force equals mass times acceleration, and then using your distance that you could use kinematics to solve for, you could get that. But yes, the answer is 54 joules, and that was by far the quickest way to go about solving it. And if there's one thing I've learned through my years of physics, is if I can do it with less work, sorry, it's funny because it's like a lesson of work, but if you can do the least work possible, that's usually the best way of solving it, because it's got the least room for error, plus it takes the least amount of time. Okay, so the next problem says a box of mass m, so mass m, slides down a frictionless inclined plane of length L. Okay, so let's draw this. So that's the length L. Okay, and vertical height h. What is the change in gravitational potential energy? Okay, so first off, we know that our h distance is going to be a positive value, okay? Because it says it's measured in h, it's not negative h. So we know that gravitational potential energy equals mgh, and we know that change in anything would be the final minus the initial. So at the bottom, you're not going to have any potential energy because the your height is 0. So it's just going to be mg times 0, which is 0. So if we rewrite this, so change in u, because ug is is a symbol for gravitational potential energy. If we say that equals mgh, I'll call this h2 minus mgh1, where h2 equals 0. We simply say that change in ug, because this whole term will be 0 because that's 0, equals negative mgh1, where h1 equals h1. So then our answer is simply mgh, negative mgh, sorry. Okay, next problem. While a person lifts up a block of mass 2 kilograms, so 2 kilograms, I'm just going to draw an arrow pointing up so I indicate that they're lifting up, from the floor to a tabletop, 1.5 meters above the floor, how much work does the gravitational force do on that book? Okay, so work equals force times distance times cosine of theta. And in this case, theta is 0 because this is our gravitational, so FG direction, and this is our direction of motion. So they're parallel, so cosine of 0, so it's going to be angle of 0 degrees. So you can solve this two different ways, but I'm just going to solve this using like this. So you've got an angle of 0 degrees, so that'll be 1. Okay, so if we think about our gravitational force will be equal to mass times 9.8. I'm just going to call this 10. I'm just going to call 9.8 10 right now. So Fg equals 2 times 10 equals 20 newtons. But if we remember, our gravitational force points down, and I'm going to define that as negative for this case because it's negative y. So I'm going to define that as a negative direction. So it's really negative 20 newtons. So if we solve for work equals negative 20, because that's your force, times your distance, which is 1.5, which I'll actually call 3/2, just to make the math easier, times cosine. I want to rewrite that. Cosine of 0. which is 1. So I'm just going to call that 1. So if we do some quick math, that would make that -10. -10 times 3, -30 joules, which is the correct answer. Okay. All right, next problem. So a block of mass 3.5 kilograms, 3.5 kg, slides down a frictionless inclined plane of length 6. So L equals 6.4 meters. So I'm just going to draw that out real quick. 6.4 meters. Okay. With an angle of 30 degrees. So 30 degrees. With the horizontal, the block is released from rest at the top. What is the speed at the bottom? So we can solve this two different ways. I'm going to solve it using energy just because that's what, typically whenever it's taught, whenever you learn work, you learn energy, and it's just a good way to practice. So let's do some quick trig to find out what our height is so we can solve our initial gravitational or potential energy, and then we can use conservation of energy to convert that into kinetic energy. So we have a h of 6.4, so sine of 30 equals 6.4, or sorry, not 6.4, h 8. You want to write for me? Oh, that's really weird. Maybe I have to retype. Huh. Well, that's interesting. Oh, I think I was writing what? Yeah, so h over 6.4. Okay, so sine of 30 is 1/2. Okay, so we're just going to rewrite that as 1/2 times, or you know what, I'm going to do that, times 6.4 equals h. So 6.4 divided by 2 equals h. So that would be 3.2 meters equals h. Okay, so now we know at the very top, it's not moving. So it doesn't have any kinetic energy. All it has is potential. And using conservation of energy, we know that at the bottom, it's not going to have any potential, but it's going to be all kinetic. So we can simply convert that potential energy into kinetic in a direct relationship. So we can say that, mgh equals ug, okay, and then k equals, oops, that was a really bad k. K for kinetic energy equals 1/2 mv squared. So we can say mgh equals 1/2 mv squared. So I'm just going to cancel out the m so I don't have to do any unnecessary multiplication. So if we multiply across by 2 and then take the square root to get v on its own, we get v equals the square root of 2gh. Okay, so if we quickly do that, we're going to multiply by 2. So 3.2 times 2 to get 2h would be 6.4. 6.4 times 10, which we're going to call gravity. So v equals the square root of 2 times 10 times 3.2 equals the square root of 64, because you've got 6.4 times 10 equals 8. So 8 meters per second would be your velocity at the bottom. So that's pretty much it for this video. Hopefully you guys learned something. Hopefully this helped. If you guys have any extra questions, be sure to go to my website, studysession.org, and ask them, because I will be more than happy to answer them for you, because I know that you can't answer every question possible in a however long minute video this has been, 13 and 24 seconds at this point. But yeah, make sure to stay tuned for the next episode, and yeah, that will be all for today.